there are 4 marbles in a bag, and each marble is a different color: red, green, blue, and yellow. 2 marbles are selected from the bag, on a table, not in a bag. They're put into a bag. Is the order of the marbles or the order of the colors important? No. This is what I was talking about before. The term permutation means arrangement and order matters. The term combination means selection and order does not matter. In word problems, it's up to you to determine if the context of a problem requires an arrangement, which is a permutation, or a selection, which is a combination. This one, the order doesn't matter. You're just going to choose 2 marbles. Doesn't matter if you choose a red and a green, red then green, or green then red. So it's a combination. So the second part of that asks you to use a tree diagram to find the number of unique color combinations for the 2 marbles. So for the tree diagram, we can start with red. If you choose the red marble first, what are your options for the other one? Green or blue or yellow. If you choose the green first, what are your choices? Blue or yellow, not red, right? Because we already did the red-green combination. We did red-green, we're not going to do green-red like we would in a permutation. Then if you choose the blue first, your choices are yellow. That's it. So 1, 2, 3, 4, 5, 6 choices. Red, green, red, blue, red, yellow, green, blue, green, yellow, or blue, yellow. It says use combination notation to find the number of unique color combinations. A combination is represented with the notation NCR, which usually you'll hear people say N choose R, where N is the number of items in our set and R is the number of items to be selected. So it works just like the permutation. It's just you're doing a combination instead. So for this one, there are 4 marbles. And how many of them are we going to choose? 2. So 4 choose 2. And you can do that on your calculator. You find it in the same place as the permutations. When you do that, that works out to 6. How many ways can 3 or 4 marbles be chosen? You're going to have to do 4 choose 3 plus 4 choose 4. Remember, or is like a plus. So 3 or 4. So how many ways can you choose 3? How many ways can you choose 4? Four choose 3, that's 4. What's 4 choose 4? 1. So that's 5. There are 5 toppings available for a pizza: mushrooms, onions, pineapple, spinach, and tomatoes. If a pizza is ordered with 3 toppings and no topping may be repeated, how many different pizzas can be created? So combination, right? Although some people may argue, it doesn't matter whether you put the mushrooms or the onions on first. It doesn't matter whether you put the tomatoes and then the pineapple, or the pineapple then the tomatoes. There are 5 to choose from. And how many are we choosing? 3. So 5 choose 3. That's all there is to it, right? And that is equal to 10. So 10 different pizzas that could be created with those toppings, if you're choosing 3 at a time. There are a lot more possibilities if you could choose as many toppings as you wanted. So this is when we start to put some conditions on. How many 6-person committees can be formed from 11 men and 9 women if 3 men and 3 women must be on the committee? So it's not quite as straightforward as the previous question, but I think this one's not too difficult. What do you think you have to do here?
Get the 3 men plus the 3 women.
Do them separately, right? Choose 3 men, choose 3 women. So how many men are there? 11? Is that what you did? 11 choose 3? And then 9 choose 3? And what are you going to do with those 2 answers? Multiply. Because you're choosing men and women, not men or women. That works out to 13,860 possible committees. A committee of 5 people is to be formed from a selection pool of 12 people. So if that was it, you'd just do 12 choose 5, right? But there are some other restrictions here. It says, if Carmen must be on the committee, how many unique committees can be formed? So one of those 12 people has to be on the committee. She's already chosen. Why was she chosen? We don't know. Maybe she's like the boss's daughter or something. What do you think? What do we have to do? Sorry?
Is Carmen a part of those 12 people?
Yes.
She has to be chosen because she's lucky. Okay. So then isn't it just 4 people?
Wouldn't it just be 11 choose 4? Yes, it would. 11 choose 4 because you're taking out one person, putting them on the committee, which leaves 11 people to fill the other 4 positions. So 11 choose 4, which works out to 330. The B part of that says a committee of 6 people is to be formed from a selection pool of 11 people. If Grant and Helen must be on the committee, but Aaron must not be on the committee, how many unique committees can be formed? So Grant and Helen are definitely going to be on the committee, but they don't want Aaron on the committee.
That's mean. Yeah, Aaron. Yeah.
How many people are there actually to choose from? There were originally 11, but we have to take out 3 of them, right? So there are 8. And how many people are we choosing? Isn't it 4?
It's 8 choose 4. Why is it 4?
4 because you need 6 people, but you already have Grant and Helen, so we need 4 more people for the committee.
But Aaron can't be on it.
Right.
Not on it.
That's why we've taken
We take
him
him
out
out
of the selection pool.
By the way, when did
So this is leading into what we're going to do on Monday, looking at all of it together and deciding which type of question is it, a permutation or a combination. So this one says, how many 5-letter words using letters from triangle can be made if the 5-letter word must have 2 vowels and 3 consonants? Is this a permutation or is it a combination? Permutation? Yeah. Because changing the order of the letters changes the word, right? So this is actually a permutation. And that's what you need to be thinking about come Monday with the questions that you're going to do is which one is it? And then go ahead and figure out how are you going to do it. So we know it's a permutation because switching up the order of the letters changes the word. It's going to be a 5-letter word, 2 vowels and 3 consonants. So how many vowels are there? 3 vowels. So we're going to do 3, pick 2, and 3 consonants. How many consonants are there? 5. Pick 3. Does that look? That equals 360. So we chose permutations because the order matters. We multiplied because you're choosing vowels and consonants, not one or the other. And the 2 vowels and 3 consonants, that makes the 5-letter word because we're picking 5 letters altogether.
No.